Today, I'd like to present to all of you guys Vladyslav Variushkin. I've been working with this person for more than 3 years on one project, and he's the most amazing guy who can do wonderful things. So after our project ended, he joined EliteA or EliteA, and today he will be showing us how they're doing testing, how the agents test the agents, and all this super complicated flow. We have numerous of things with him where he's showing day by day what they're doing. So guys, this stuff is crazy, and Vlad will tell all about it. So Vlad, the floor is yours. Thank you so much for coming to us.
Yeah, thanks, Alisa, for introduction. Yeah, my name is Vlad. Yeah, currently I'm a test lead at EliteA project. Yeah, and we're just following this trend. We're trying to be an AI native. So let's take a look what we are doing, right? So let me quickly share my screen. And let me know when you see it. Yes, no, because sorry, I don't see you.
Yes.
Yeah, okay,
yes,
cool. Yeah, so let's start real quick. Just this topic that everybody is talking about having AI native team or having AI native processes and all the stuff related to AI, being AI native. So EliteA is not that different, right? Because we're actually the product that builds the solution for building agents and everything related to AI. So for sure, our team is AI native. So let's quickly check our QA AI native, let's say SDLC, right? So mostly each point that we are facing at like QA lifecycle, yeah, is supported by agents. Yes, something is like assisted, something is fully agentic, right? Something needs human in the loop. So as you see, so for our project, everything starting from the story analysis, ending with reporting and documentation creation is fully AI infused. And today I would like to talk about more how we're doing some agentic stuff, and it mostly related to test execution, test analysis, and reporting. Yeah. So out of these blocks, right? So story analysis is kind of understood. Yeah. Test planning, like this is kind of simple stuff, right? I guess everybody has such agent or something, right? But here, test execution, analysis, and reporting, this is something more interesting, at least from my perspective, yeah? So here at EliteA, we have fully agentic piece, solution, let's call it so, for these 3 blocks. So AI executes the test, AI analyzes the test, AI reports the bugs, right? So that's what we would like to talk about. And I would like to set the ground. The goal, like what I will show you, is to prove that AI can actually test AI. Since you already know that EliteA is full AI platform, yeah, we were able to utilize each component of EliteA itself just to test EliteA. So let's dive deeper. So we call it EliteA SDK testing framework. So what is EliteA SDK? Just in the simple words, this is like the main runtime that does pretty much everything of what you're clicking on EliteA. Whatever you click on EliteA, like you create an agent, create pipeline, I don't know, talking to the chat, you add in toolkits, whatever, right? Eventually, everything of that lands to EliteA SDK. And inside EliteA SDK, all these runtime pieces happening. And let's just have a quick overview so you understand how the flow is going inside EliteA SDK, and then you will see that some of these pieces are actually used in our, like, let's call it so, automation framework or runner, right? Whatever you call it, right? So let's have a quick look. So everything starts from front end, right? So someone like clicks something on front end, like for example, we create an agent, right? The agent is created and you try to ask the agent for something, right? Just calling the predict, right? And that's the flow that goes inside the EliteA SDK. So the request coming from UI, yeah, then there is EliteA client that supports LLMs and etc. Yeah, EliteA client can create assistant, and assistant can create actually LangGraph. LangGraph is something from LangChain that actually executes all these flows, right? LangGraph is usually built of several nodes, depending on how you like select them from EliteA UI, right? And these nodes may have toolkits. Yeah, so basically, within this framework, we're trying to test the things that are called toolkits. Because if you're aware with EliteA, right, we have a bunch of toolkits, more than 40, right? You can create Confluence toolkit, you can create Jira toolkit, GitHub toolkit, and all of those toolkits have numerous of tools, right? And that's what we are trying to test mostly with this framework. So we would like to make sure that when you attach, for example, GitHub toolkit, right, then you creating an agent that, for instance, will be creating PRs, for example, for you, right? Then we would like to make sure that create PR tool is actually working. So that's basically the main goal of this testing. But as you see, to land to this like toolkits, we're actually going through all cycle. And this is like the bonus, right? While you're testing toolkits, you're actually testing all EliteA stuff, right? And from this slide, let's go further. I can show you what actual like pieces from previous site I used in our framework. So LangGraph for sure, right? Because we will be building pipelines, you will see them further. And the pipelines, there's something executable, right? And pipelines have numerous like nodes, right? And this LangGraph actually wraps them all and then comes to runtime and executes all of them like in pipelines. We're doing that sequentially, right? And then EliteA client, this is like the LLM, yeah, because we have also cool stuff here. We don't do like regular assertion, like assert that something equals something or doesn't equal something or contains something. Yeah, we actually go in full AI mode. We're doing AI assertion. So we just literally like telling AI, go ahead and verify that I have it there or I have something there. So fully like English, no coding at all. Let's call it so codeless solution, right? And for sure, we have EliteA agents that doing like the stuff after the tests are executed. So we have this guy, which is called PR Impact Analyzer agent, because from these toolkits, as you understood, this is kind of end-to-end test. So we need to call real GitHub, for example. We have to call real Confluence and all these pieces, right? To make sure that toolkit and tool is actually working, right? Since these tests are like kind of heavy, yeah, as you may imagine, because a lot of API calls and all this latency and all this stuff, right? We need to do we have to execute them smart, right? So this is the solution in here. So we have PR Impact Analyzer agent. Anytime the dev tries to commit something to EliteA SDK, the agent knows the structure of the EliteA SDK, the dependencies between these like components, right? And the agent knows how many tests we have and what tests are covering, right? And this agent is able to select out of, let's say, 500 tests, only 12 tests. And that will be enough to verify that wherever dev is touching is actually working after he has touched it, right? Then, for sure, after the test, like executed, we need to understand if they're failing or not. If they are failing, there is this guy that test fixture agent. So what it does, he tries to understand why the test is failing. He understands if this is like test issue, I don't know. We missed some syntax in this YAML, right? I don't know. We didn't make the proper like sequencing nodes execution or something else, right? The agent is able to classify, is it a test issue or is it actual client issue, like in our EliteA SDK, right? So test is written properly, right? All these like parameters, etc., context is passed properly, but there is still a bug. This agent is able to understand that, and it highlights these issues to the next agent, which is bug reporter, yeah? So after this agent has analyzed all the stuff that we have, he has classification, like automation issue, SDK bugs, for example, if there are any. Or if there are no bugs and this is flaky test, this agent just runs the test, sees this, it passes on the next iteration and go ahead, it skips it. And then it lands to bug reporter, right? And the bug reporter does also cool stuff. It does the duplication, it actually creates cool bugs like with clear description, with clear steps to reproduce, and even can do RCA, right? So then the next agent that comes to fix this bug just reads all this like grounding and is able to fix actual bug without additional investigation. That's kind of how we have it like from component wise. And this is like the pipeline, right? This I kind of touched that, right? But that's how it actually goes. So PR is created, yeah. PR analyzer comes on the stage, right? He understands what points are touched, right? And selects proper test, like the test that it thinks have to be executed, right? Out of all the tests we have, right? Then actually test execution phase is happening, tests are executed, right? Then if the tests are failing, then there is a text fixer. If the tests are not failing, then just pass and like exit the pipeline, yeah? So the test fixer understands, classifies, fixes the test, and like then highlights any like issues that where we have to report the bug. So this guy test fixer is unable to fix the test or it is in doubt. We need human in the loop, right? Let's go. So that's why we're creating these bugs, right? They'll land into our board and we like automation teams knows what bugs to look for if this automation bug. The dev team knows what to look if it is not automation bug. That's the flow actually, right? And then that's how actually our tests looking. And as I mentioned before, no coding at all, right? This is like straight up YAML file. And in YAML file, we have these nodes, right? Since we're testing toolkits, for sure we have toolkit node. So if I would like to test, I don't know, GitHub toolkit, I just attach the node with GitHub toolkit and I select the tool that I would like to test. And then, like in simple automation, just you do something, validate something, clean up something. If you need to create something before, you know, your validation, you need some test data, for sure we can do this. So the flow is the same like in traditional automation, but the test is not like in any coding language except for YAML. And that's actually how our tests are looking. This is just like overall, this is not the real test, but pretty much, I guess, explains the idea. So for example, if I need to test that issue is created, so here the tool is called, right? The next node is called, and then result of this, like tool is passed to this LLM node. And here I'm asking, check that my issue is created and it has valid number and blah, blah, blah. Yeah, that's how I'm checking that. And then for sure I'm clean up in it all. So that's pretty much how we have it here. And I would like to show you like the real examples, like what the output, what the outcome, and how it is actually helping us like in our like everyday life cycle. So let me real quick share, change my screen. So the tests, right? So as I mentioned before, those are pipelines, right? So here in EliteA, you may know, I guess, we have these pipelines. So here I created some tests. Those are actually real tests. And here you see, as I mentioned before, all these tests are actually the blocks, right? The nodes that we are able to create here. So this is the flow, right, which is going in our test. So we like prepare issue, create issue, validate the issue is created, and etc., etc., etc. The benefit of that is also if we spot the bug in here, we can actually save this pipeline, right, and then like pass to the dev for debugging or like use it as actual test data because this thing has like reproduced the bug or found the bug. That's how it actually looks like, and for sure you can like call pipeline from here just to verify that it's still like not working or like it is automation issue or something. Yeah, you can go a lot of ways, yeah, from here. So this is basically how we create in our tests. And let's see how it is going in PRs. So I have a few examples. So, for example, yesterday, right? We migrating in EliteA, we migrated to different space, right? And we have to do some kind of code migration. Yeah, so I need to like re-prepare my test infrastructure. So yesterday, right, I thought I fixed everything, yeah, and created a PR, right? And then I actually executed the test for ADO because the only test I touched was ADO. And then look, it says, so I forgot to pass toolkit ID, but there was not the issue. So this is actually how it works, yeah? So the test we ran, right? And then you see like 42 out of 42 failed, yeah? And why it is failing? And for me, I don't even have to like go inside the code, right? Run the test myself just to understand why it's happening. I already have everything in here. So my agent says, automation bugs. And here is the reasoning why this is automation bugs. Reasoning pretty much cool because everything it says in here is actually right. Because from automation perspective, I forgot to like apply the changes I had to apply. That's why the test for sure failed. Then this guy like told me, okay, you forgot to do this. Okay, here you go, receive the bug. Okay, this is the bug actually. The agent created, this bug creator agent, yeah? And so here the bug is pretty much descriptive. Yeah, you see we like how we know the bug is AI created or not AI created. Simple as that. We're just labeling them. You see AI created, it means it was somehow created by this agentic pipeline. So we know where it is coming from, right? And here we have some labels, automation bugs is just for me because I'm the part of the automation team, right? Devs should not look in it. I am the one who looking at it, right? And found by automation, it is like we're just collecting the metrics, how many like bugs were created actually by our solution. So just to see how it is working. So this is the bug, right? The bug is pretty much descriptive. You see all the steps to reproduce, actual result, why it's happening. And here actually investigation required, yeah. And also it says root cause, right? So just read it, and if you have another agent that is able to fix the bugs, I'm just passing this bug to another agent, and the agent goes ahead and fixes the bugs. So this is one piece that I wanted to show. Here, there's another like stuff. So for example, here, dev created the PR, right? And our agent is also able to spot PR regressions, right? So for this, so PR is in review, right? But not yet merged. So we do not create the bugs for these stuff because it's not yet merged. It's not considered a bug. But our agent is able to actually spot PR regressions. So here, this is the example. The dev pushed some changes, yeah? The test failed, and it determined why they failed, right? And says, okay, you touched this like LLM pi, right? This is the piece where actually everything is happening. This tool close, tool results, that like enrichment, etc. Everything is happening here. So this PR actually broke all this like structured output. And here the classification, reasoning, everything is kind of on point. So dev just look at it, okay, oh boy, okay, I will fix it. He went and fixed this bug. And again, he did not have to investigate it because all investigation is already in here. Dev just knows what to do next. Also, the cool stuff in here, sorry, I will remove this guy. Okay, since this is kind of agentic, our test may be self-healed. So I have a dummy example here, but it happens for whatever test like AI miscreated, right? Because for sure we're creating all these tests using another agent, right? And look here, for example, this was dummy commit. I intentionally messed up the test, right, and ran the PR. Okay, this PR check failed, and here in this pipeline, I will show you. You see, first off, yeah, this like impact analysis. Since I touched only one test, this agent understands, so no need to run anything else except for one test because I literally touched only the code in one test. So it like selected everything properly. No need to run 500 tests that we have just to verify that this test is failing, right? So then you see it actually failed because it had to fail. And then the agent detected, okay, he sees, look, guy, you have an issue here, but your issue is that like you messed up the test. Let me fix it for you. And the agent like applies the fix, verifies the fix within PR, right? Before pushing it to like the actual PR branch. If the fix is applied, if the fix applied misses, the test is passing, right? This agent just commits this fix to my branch, and then I don't have to do anything, right? Because the test is already self-healed. And here we have only cool, like, metadata, let's call it. So this is like the reasoning of the agent, why it understands this is SDK bug or not SDK bug, like it's automation bug or not automation bug. We also like tracking what agent is trying to do. We call it fix milestone, because it tries to apply one fix, okay, it doesn't work. Next fix doesn't work. Oh, the third fix works. So the agent knows what he did before, so he doesn't reapply the same fix, I don't know, 5 times in a row. This is like cool metrics, not metrics, like cool metadata that helps us first place understand what the agent is doing there instead of going to check all the logs. And then like if we spot some issues here, something is not fixed, we just tune in the agent. Like this is kind of observability, let's call it so, but you have to read it for sure, but that helps a lot. This is like the piece, and actually what's going inside, I can show you here. So you see, if we go here, test ran, right? And then do AI analysis. So here the agents comes in, right? Like he reads the reports, he reads the test case, he reads the structure of our test framework and the EliteA SDK, and he tries to do something. Like he debugs it, like he runs the test right inside here, like within this pipeline, right? And then if he spots the pain point, he tries to fix it. And for this case, you see he pretty much fixed it. And instead of this pipeline being red, it's green because test is self-healed. And also I can show you this piece. That's how it looks from PR. It's again like something that helps you developers or like any team members to understand what is actually happening. This is pretty much what is going on in PR. Like the agent tells everything what he did. You see this like the full stack of issues that you can imagine like within our infrastructure. You see this PR brought up regression. We had some flaky test. The agent ran it and it passed. Like as I explained before, since we call in real APIs, sometimes it happens, right? So flaky test may be there, but the agent ran this test, and on the run, like within this pipeline, it passed. And there are some actual bugs except for the PR regression. The agent spotted that, and the agent logged the bug. You see in here, the agent created SDK bug, this is the client bug, automation bug, and also the agent is able to find duplicates. If it finds duplicates, it doesn't create the bug, it just highlights, okay, team, we already have the bugs, we have yet to fix it, but here's there. So we decide whether we want to fix it right now or it's enough to postpone it. So that's pretty much how we're doing it here. So I guess I'm done from my side. If you have any questions or if did really so, Alisa.
The one question I see in the chat is the person asking like, if basically this approach can be applied on other projects.
Yeah, look.
And from your experience, like remember your previous
experiences. I got. Yeah, this is the question is simple and tricky at the same time. This thing may be applied to whatever project you would like to apply it to. It depends on how you structure it, because only thing you need is have proper prompts and the tooling. From this side, since we're using EliteA, we have the tool that has access to actual code base, for example. Yeah, this facilitates us with exploring the code, right? So that's why it very simple way to understand what is happening. Maybe if you will be using GitHub MCP, that will be more complicated for you. It will be heavier, right? But for this piece, I don't know, you can apply it to whatever project you would like to apply. The only point, you have to understand how to structure the failures. If you have this knowledge and you have already past experience, you can create the agent that will analyze your past experience, and that's it.
What about self-healing part? Like imagine regular pipeline, you have some tests failing, and then I want them to be rerun, analyzed, and self-healed. Regular UI or API tests. Can that be done with similar approach?
Yeah, but this is how we do it here. Oh, you mean like, okay, Java-like or something?
Yeah.
This actually can be done because how this agent runs the test. We like adding the skill, like to run the test. The skill is like command line interface. If you're able to, whatever you like tool you are using, right? If you're able to supply the agent with the skill, the agent will do it for you. So the only thing is to teach the agent how to run certain tests, not to all tests, right? Like 1, 2, 3 tests that will fail, and what to do with them, how to classify, and how many attempts to apply. So the philosophy here is like so, right? I see the issue. If the agent is unable to fix it within 4 attempts, go ahead, create the bug. So that's like exit criteria. Any other questions? Suggestions?
The other person is asking if you can show skills, tools, or context, how it's organized. Can you do that briefly, or it will be too long?
That, I guess, will be too long, but you all know that EliteA SDK is public. Go ahead and like check it up there. Everything is there, like it is within.
And your testing framework is also there.
Everything there. You just literally
Then you
can
post
try
the
it.
link.
Yeah. Everything is there. Yeah.
Ravil is asking if the backend code, how the backend code is sent to LLM.
It's simple as that. Tool. We have the tool. Since we run in EliteA from EliteA, so EliteA actually a runner. So, and where we run in the tests are ran within this code base, right? So I'm just telling the agent, okay, here's out of stack trace. It says, okay, failing like class so and so. It just goes ahead, grabs the file and scans it. You just attach it like a, a file system tool. That's it. So literally, like on your computer, you go ahead and scan the like Explorer. Here, the same approach. Nothing fancy, actually.
Okay, I think the way will be to get the solution and explore ourselves.
Maybe, yeah.
Okay, guys, you can unmute and probably ask the questions or raise the hand if you want to just talk.
I guess Anton. Yeah, Anton.
Go ahead.
Oh, they say that.
He has
okay.
control. Nice.
Mhm.
The question is how to deal with the false positive scenarios. It means like we may trust that the agent like did the job for us.
Yep.
We just may miss some specific fix like applied by this agent, and then we will have like just the not flagging, just false positive test that will give us like just green pass.
That's right. But like the simple answer, no one guarantees that human will not do it. Like this is the simple answer. But like this is like some corny, right? But here from my side, what I did, like I was monitoring what the agent is doing. I tried to supply it with different like use cases, I don't know, issues, etc., etc. And I was spotting, I had this issue also. Agent tried to make the test green, not the like detect the bug or just fix the test like from, I don't know, this like variables perspective or something more like related to technical stuff, right? It tries to like simplify the assertion, try to remove the nodes, etc. Yeah, just for the test to pass. That's what I was like checking on, and I was tuning that within the prompt. So for sure, if you like the answer is so, if you create like something like that and go ahead and push it to production and without monitoring on something tuning, you will end up where you telling you will end up. Yep. You just have to monitor and you have to spot these issues. Because the agent is cool, but someone has to think how it will work.
You should always be aware.
Yeah.
Just how often you just mentioned that the agent tried to
mess up? Okay, understood. Yeah, at the first stage, I spent, I don't know, maybe the week. Yeah, and I had it was cool stuff. I had a lot of PRs from dev, so I had a lot of different points of view. Yeah, and I spot, okay, here it messed up. Here, he didn't do what it had to do, etc., etc., etc. So I spent a week for tuning it, and now I haven't touched that for, I don't know, maybe 2 months, and whatever bugs is coming, this is the bug. We are not missing that. It is not coming to UI and our manual team. It's not manual team that finds the bug, right? The bug that this solution has to find, it finds it right here before it goes to environment.
Great, thank you.
No problems.
All right. Anyone else? Raise your hand if you have any questions. If not, Vlad, then we are waiting for the link.
Okay.
Please.
All right.
And this was great. Thank you so much.
Thank you.
To a lot. Thank you. Thank you, the
Bye-bye.
audience. Thank you.
Thank you for coming. Yeah, bye-bye.